Today we're going to look at a couple of new motors for the 2019 season. These are for 2S competition racing, and we're going to be looking at them primarily for use in Blinky class racing, i.e. non-boosted speed control settings. And the ones we're interested in again is the 13.5 and the 17.5. Tested loads of motors up to now, and got some class leading ones like the R1 Surpass. We can compare them to those and see if there's been any improvement. We'll look at special features they say they've got, and I'll do all the measurements like I've done before. And there's a couple of critical measurements will show up whether they're better or worse than what's been before. Now, I was going to do 3, but I managed to get 2, and the third one I haven't been able to get. So let's have a brief look at what I'm going to test. There's a new Fantom Icon motor. Previously they've had, they bring out a new one every year, and this is the latest one, the Fantom Icon. I managed to get a 17.5 version to look at. I've also managed to get a new SMC Low Rider motor. This is a 13.5 turn, comes in this cardboard box, and it's one that has got a minimized cosmetic can, small diameter. The other one I was hoping to get was the Revtech Xfactor, but I haven't been able to get one, so we'll just look at the picture and read about it. At the moment I believe you can only get a 10.5 and a 25.5. You can see from the picture can has been totally cut away at the front. On the back, first when you look at it, it doesn't seem to be any way of adjusting the timing. There are 3 screws just go in there. Now, one thing about these screws, they just screw into the back of the can. The whole can just slides on from the front, and just 3 short screws there. So there are none of those long screws anymore that go all the way through that some people think takes away from the performance of the motor, and they've been putting titanium and alloy screws in. Get around that, manufacturers are starting to do this now, doing away with the screw. The front, you've got these massive cutouts, and it's very open at the front. I haven't got a picture of the front, but there's just the motor mount screw holes and about 6 screws. Now the back, as I said, doesn't seem to be any way to do the timing. You can just see the timing marks around the bottom. And what happens is that you just loosen these 3 screws off, and you can rotate the whole back plate. These little 3 screw holes here are just screws from the other side that just hold the sensor board onto the back plate. So that's quite interesting, and I haven't seen that before. Let's just see what they say about it before we move on. Power yourself to the next level. Say it's 10% lighter, weight 148 grams. They say it's lighter than previous motors. That'd be lighter than their own previous motors. And 148 is very lightweight. But I can't weigh it, but let's just assume it is lightweight. New sensor board. Well, all the manufacturers keep saying they've got a new sensor board. Every time I look at them, they seem to be the same as what went before. So take that with a pinch of salt. Yeah, full timing adjustment, good. A revolutionary timing ring and locking end plate that saves weight with 6 short screws. Yeah, we looked at that. That is good. X-flow cooling pulls more air through the can, reducing motor temperature. Well, I'm not sure what they mean by that. I don't think there's a fan on the end of the rotor itself. I mean, it's got massive holes here, pulling the air through. Well, there is a tiny gap between the rotor and the stator inside where some air can flow down, but it's got to flow out on this end as well. And I don't see any exit holes on this end. I don't think these are open, but they may be. So maybe you can get through somehow. 2-piece machined aluminium can for more accurate deviation readings. I assume they mean for less deviation. Well, it is a 2-piece can. It has to be, because it's 1 piece all the way up to the back, and then this piece is screwed on. Ultra low resistance solder tabs. Well, they look like the wraparound type. I can't quite see. Yeah, I'm not keen on those. It's like a piece of circuit board plated on both sides. Plating has to be really substantial, compared to a solid metal piece, but maybe it's good. Stator design, more efficient power curves, no fade. Well, we haven't seen a new stator design for some time that has to meet the regulations on size, so unless they all tend to use the best steel laminations they can. So it comes built stock with torque and punch. Their previous motor tells you the size, high torque rotor dash copper. High torque rotor dash copper. Not sure what they might mean by that. The rotor has to be made of magnetic steel. 10 and 5 and 25 turn are currently the only Xfactor turns under full testing and development. Other turns will come later down the road. Up here it says meets all raw specs, approval pending, and they do call it the spec class brushless motor, so if it passes you should be able to use it in your Blinky class racing. It's the SMC. Interesting, they talk about small diameter now because a lower center of gravity. It says here are in talks with Rotor to sort out an issue. We recommend tracks use BRCA approved motors. I don't know what the issue with RAW is. Patent pending, well, loads of motor people say patents are pending. Doesn't mean that they're going to get the patent. RAW approval pending. BRCA approved. Okay, it says it's approved, so good. They say it's been very successful. Low riders previously. The heart of the spec version, optimized stator. Well, the optimized stator, I'm not sure what they mean. Let's find out. After several different design approaches, we found what the unique low rider configuration needs for phenomenal power in the ultra competitive spec classes. So they say we found out. As the motor is inherently light, we will keep steel in critical areas to squeeze every ounce of power from the motor. Well, the steel is besides the rotor, is the laminations. You can't go below a certain length to meet the rules, and also you've got to have room for the rotor to go in, which is 12.5 millimeters, so you can't make the hole smaller, which I'll show you on another motor that is not legal, is smaller. I'll have a look, see if they've found another way of doing it. One way manufacturers improved the other year was get rid of all the plastic and that on the stator so that the windings could be wound very tightly onto the metal and not have those big plastic formers or big insulators and things which are pushing the wire further out and causing the wire to be longer and more resistant. So all done away with that, all the top ones anyway. In SMC tradition, motors are not sorted to keep the best for ourselves. Best motors have not been cherry picked. And by the way, I buy these motors myself, they're not given to me, so they haven't been cherry picked and given to me either. I buy them out of my own pocket, off the shelf, and they're the same as what you'll buy, what I test. Say certified stators, every motor have a stator that is run to very tight tolerances of 0.5 of a milliohm. Well, we'll measure that later. ABC, it's 34mm diameter, we'll check that's the actual diameter of the motor. Offset mounting holes. Offset mounting holes, yeah, I didn't see that. Allows the motor to be mounted lower than others. Yeah, 50mm length, well, we can measure that, that'd be front to back. And keeps the weight in, yeah, optimal weight balance. Only 137 grams, if it is, that will be the lightest on the market. Size of the rotor, yes, will be 12.5mm diameter. We measure the magnetic part, the length, the longer the better. Lately gets more performance, we found that out, though it does increase the weight of the rotor slightly. Due to the high magnetic flux inherent in the stator design, unloaded center deviation tests may appear to vary between bench tests. This is normal, not factor. Unloaded motor, well, that's another way of saying it. If the sensor boards, the manufacturers have so much trouble getting the sensor boards to be equal, A, B and C. They try and they still, some are great and some are out. And what they're saying is that, well, if you test it and it's out, don't worry about it, or it'll be alright on the track, it'll be alright on the day. Caution about time. This motor has lots of kV. Well, we'll find out about that. Testing has shown best results with timing 8 degrees less than conventional thin leg spec motors. Thin leg? Well, we'll find out what they mean by what leg they're standing on here. Check your temps to figure out timing again. Well, that's normal for any motor. 8 degrees less, lots of kV. One way you can get lots of kV is have a weak magnet, but I'll be testing the magnetic strength and everything else. Maybe this motor will be awesome. We'll find out. I'll just go over the Fantom next before we have a look at some of the claims on that motor. Fantom comes in their traditional cardboard box that they've been using a very long time. They've gone the full, quite a nice red colour, but they've had blue and they've had red before. This one is red with aluminium detailing, quite nice. A lot of people prefer black. Pretty conventional looking, holes for cooling, see the stator, see the windings. Stake tags are just like you get on the surpass motor. Very solid front aluminium. One thing you can notice straight away, it's another one-piece can that goes all the way down to the back, and it's just fixed on by 3 screws on the back, like this one, but in a different way. This had the 3 screws screwed in that way. This one got screwed in that way. One-piece can, done away with the screws that went from front to back again. So that's 2 motors that have come up with a way of doing away with those screws. No need to worry about your screw. Can't sleep at night because it's steel, not aluminium or titanium. This one, conventional 3 screws on the back, doing the timing here. Designed in the US, proud, groundbreaking technology. Don't know about groundbreaking, but let's see. Another patented design, pending tuning pins. Well, these 2 key elements will be a total game changer for your racing program. People get excited. Our patented design stator provides maximum torque while producing the most insane RPM ever seen before. Again, on the SMC they spoke about that as well. And we've added the ability to fine-tune your motor via patented tuning pins. I've said that twice now. That's correct. Another first from Fantom. With our unique design, once again, totally eliminated the need for stator screws. We've replaced them with tuning pins. How many more times? Which allows you to fine-tune the torque versus RPM in your motor. Why settle for an all-purpose motor when you can have a motor designed to fit your exact application? I thought this is an all-purpose motor if you can tune it for torque or RPM. A bit contradictory there. Anyway, we know what they're saying. They're bigging it up. Up your game and see for yourself why the all-new Icon truly is a game changer. Whether you race on-road, off-road, 1S turns, we got you covered. All R&D done in the USA, patent stator design, precision machine one-piece can, centre band of can designed around stator for better heat dissipation. Well, they mean, I guess, the cutouts. If they want the best heat dissipation, I assume you better not have anything around the stator. Anyway, high power, low resistance, 3mm aluminium silver plated collector ring. This ring is very important. The part of the front windings terminate and the current passes round from one to the other. As massive as on the Surpass and the R1, new patent tuning pins again. Precise tuning capabilities. I don't know why the tuning pins give you precise tuning capabilities. Surely that's done with the 3 screws on the back for turning the sensor. Anyway, high strength heat resistant magnet formula rotor. Well, every motor has that. Sensor board designed for improved deviation accuracy. Again, they've come up with this word, deviation accuracy, which was also appeared on accurate deviation on the Revtech one. They all copy each other, it's weird. Improved deviation accuracy, they mean minimized. Well, the accuracy is improved, but the deviation is minimized. It's a weird way of putting it. Anyway, we know what they mean. New venting designed to maximize heat dissipation. Yeah, that's holes in the can. New maximum size allowed pure copper wire. Well, everyone who's any good does that, using the best wire they can buy. No one uses, well, actually, Some of the cheap motors use thinner wire and probably cheaper wire, but the days of using these top quality motors don't use cheap wire. They don't save a few cents by using cheap wire anymore. Meets all raw BRCA specs, premium grade Kawasaki steel stator plates. Well, they said that before on their previous motors, and as far as I know, I don't know about steel stator plates, how many manufacturers there are, but if these are the best ones available, then that's good. D6 element end plate, precision bearing alignment, well, yeah, they all have that. Maximum adjustable time and high RPM precision bearings. I will be testing them fully. I'm going to take them apart and test them. Now, as you know, I do test them on the motor analyzer. A lot of people say that don't give you any meaningful results, which is not true. It enables me to set them up for Blinky racing at least. It does give the kV, and they're all boasting about the kV, and it won't give you the torque. Get it from the Gauss reading. Let's just have a look at the SMC and how you can drop the motor down. The screw holes here are closer on one edge, further away from the edge. That means the motor will sit lower in the car. So they did think about that, and that came out good. Now let's check the diameter. It's 34, but now that is not the first motor to be a 34mm, because the Orion Ultimate stock, which came out well over a year ago, was also a small diameter motor of exactly the same, 34mm diameter, so they're not the first. It had offset holes as well, but it is nice and short. They say the motor's short, and they have managed to get it a lot shorter than they used to be. The front, there's a huge gap. It does use the screws go from front to back. They haven't and they need to, because this is two parts. There's a front case and a rear case. They push together on the stator, and it's squeezed up and held in place. 725 by 12.5, that means it's a spec rotor. It has a 7.25 core. We've always determined the Orion was this diameter previously, and I'm going to show you about this innovative exposed there. If I show you this Trackstar Turnigy Outlaw motor, which has been around for a very long time, and it looks pretty ordinary. They're cheap. This is the Outlaw version. We've got another one here. You can do away with the can. You can take it off, and it bolts together exactly like the SMC. These butt up against the stator. Got a screw in there, pulls it up tight, and it's rather similar. I don't know if anyone ever did this in the past, or whether they always kept this on. But that is just something I wanted to show you. 34, just a tiny bit over. The other one was 34. Length of shaft, I've pointed out before that these are now very short, with the flat going right down, so you can get it into and get the pinion on without this pressing on the lipo. The same short length on the Fantom. It's long. I've still gone long. I don't know if you can see that gap there. One more thing about the Fantom, they speak about high RPM, and well, if you look at that, I don't think the rotor is very strong, which will give a high RPM, so it'll be interesting to see how the readings come out. Surpass, for instance, are very strong, as is the R1. We've already seen this one's ultra strong as well, as was the Turnigy Outlaw. Whereas the Fantom is. I've taken apart the Fantom Icon, the SMC Low Rider, and also the Turnigy Outlaw motor to show the differences inside between them, and also to find out about these special features that each one says they have. If you look at the SMC Low Rider, they say it's different to conventional thin leg spec motors, and you might wonder what that is. Tried different design approaches, and as the motor is inherently light, we could keep steel in critical areas to squeeze every ounce of power from the motor. Now, steel in every area, critical areas, well, the steel is in the rotor, which has to be a spec sized rotor of 12.45 millimeters diameter. So we're not talking about that. The length of the magnetic part can vary. The manufacturers have gone up a little bit lately, which has given a little more performance. But that's not what they're talking about. They're talking about the steel in the stator. Now, these are loads of laminations that are squeezed together to stop eddy currents flowing and losses. What does this stator do? It's got the wires wound round it, and it's a piece of steel and wires and connections. Well, let me just show you. I've cut one open here. 3 sides to this. It's got a steel part there and a leg. 3 of them. And that steel part there goes up, and it goes all the way around the outside of the case. Now when these current flows through all these coils, you can see all these copper coils. They've been round each leg, so it's 3 windings. That's your A, B and C. Now I've cut the front off. It would normally go up and out, round like that. I've cut it off. Still got the other side where they come through and they're all connected together. Now these are round each leg, 1, 2, 3, and these are the thin legs or thick legs that SMC are talking about. You want this to be as thick as possible, because when the rotor, which is a very strong magnet, is inside, when you pass current round this coil, it generates a magnetic field, a north or a south, depending on which way the current's flowing, and it attracts the north or the south on the rotor. And if the north is over here and that becomes a south, it will spin it round till it reaches the north and south face each other. Then what happens is that current turns off, and the current turns on the next coil to a south, and if this is a north, it'll move round, and it keeps stepping around like that. What difference does the metal make? Well, under the rules, you can only go so narrow, front, back. There's a minimum number of laminations. Now, the laminations themselves have to be made out of a special steel that passes the flux density easily through it without any resistance, like amps passing through a wire. If it's a very thin wire, the amps can't flow, and it heats up, same as this. If this metal part here is very thin, the magnetic flux has difficulty getting through, reduce the strength, or it can also cause heating as well. If you look at this bottom part here, it's a little curved part. They're not joined. There's a gap in between, and the magnetic flux force goes into that as well, and it enables that face there to be wrapped around the magnet, and that also affects the way the motor works. So now we've got a leg that's wide, and you can have a thin leg. And the reason why they have wide and thin, the thinner it is, the easier it is to wind all these copper wires round. You can only use this up to a certain thickness, so you want as much copper round as tightly wound as possible, with no air gap left, to get the lowest resistance. Well, if you had a very thin leg in the middle, it would be very easy to wind the copper very tight, and it would be shorter, less resistant. But you will lose magnetic force through a thin leg. And also, this whole thing is quite heavy. If you want to reduce the weight, you want less steel in it. You can make this thinner around the top. It gets lighter, but the magnetic flux won't pass through, and you start losing performance. The SMC I tried to look inside, but I don't want to cut it open to see how big the leg is. I can't see, but one thing I can see is that this part, these three little curved parts that wrap around the rotor are quite nice and thick, which means that the magnetic force doesn't have any difficulty with flux flowing across the little air gap and up there. So that is good for lots of magnetic strength, and that motor feels nice and strong. Conversely, on the Fantom one, you may not be able to see, but that lower part, that curved part on there, is very, very thin. It's wafer thin, wafer thin. I can see that it's almost thin enough that you could snap it off. And also the leg up the middle, you can't actually quite measure it, but it does look fairly thin, which means it's very easy to wrap the wires around. And that is why I wondered why this Fantom motor, why the magnet felt so weak. I thought it must be a weak magnet, but no, the rotor in there is actually a very strong magnet, and I did measure it, and it was over 1500 Gauss. It just goes to show that the design of the stator and this thin leg, thick leg, will definitely affect the magnetic strength of the rotor passing through. And this one is particularly thin, thinnest one I've seen, I think, ever in the Icon. And this one is nice and thick. This is a motor from a few years ago when the resistance windings were much higher, and they used very thick material all the way around. But now, because they're trying to wind the maximum gauge of wire they allowed, they've thinned it out a bit to give a bit more space so they can get the wires in. Another thing I'll just mention about this, for those people who are interested, this hole in the middle is normally a standard, normally 14.5 millimeters tube, and that is like a perfect fit in there, and it will be on these others. And the SMC the same. Spec size rotor, which is 12, nearly 12.5. And that goes in. You can see there's quite a gap, air gap. There needs to be some air gap. When you put a 13mm rotor in there, these things start running pretty hot, and the magnets get very, very clunky because the magnetic attraction is so strong. Anyway, that's a standard rotor, the standard size hole. Let me just show you the Turnigy Outlaw, and it's similar to other Outlaw motors. The hole in the middle is really small. This won't go in at all, and if I put the spec rotor in, it just fits, but there's no air gap whatsoever. And these motors run a smaller diameter rotors, about 12.3mm. And what's the point of doing that? Well, it's enabled, there's a bigger gap now because they've dropped this middle part down. This part is lower, which made this whole area here bigger, which means they can wind multiple turns. They can get more in, and even though it's only say a 17.5 turn, which this is, they can get more wires. Maybe they can get an extra couple of 2, maybe even 3 wires in the bunch round, and that gives you a very low resistance. But that, under the rules for spec motors, that's not allowed. So that's how the Turnigy Outlaw gets such a low resistance with the coils. Got a very powerful coils on it, and also very strong magnet. It can also use, when you use a smaller diameter rotor, it weighs less, which helps with the response time. So that's what's going on with the thin leg, big leg thin face and all the rest of it on these two motors. So I think that just about explains the SMC, what's going on there. The rest of the SMC we can look at. It's a very standard sensor board. They still have trouble with this deviation. They say don't worry about it. It's just a way of telling you there's nothing really they can do about it. So you might as well not worry about it. Standard end belt, a few parts. Only 2 screws. They obviously think 2 screws is sufficient for locking it in position. Standard size bearing. Still got a paper gasket in the back. It's really there just to stop you dropping soldering, I think, and shorten it out. I don't see any other reason why they put that in. 2 parts pressed together. It locates nicely on the ring that they've recessed around the end of the stator. But also to make sure that it lines up, what they've done is they've got these little inserts which are plastic, as far as I can tell. Now one thing you want to do, the reason why there are lots of laminations pushed together and why this isn't just a solid block of steel, when you pass a magnetic field through it, you get eddy currents go round and round, and they can generate a lot of heat. So what they do is all these laminations are insulated. You can't tell, but they've got little thin bits of insulation on them. When they're all clamped together, they're not shorted out together at all. Each one is individual, and it stops the eddy current flowing. But besides that, when you put a screw in, a big screw, if it presses against the side of the laminations, it shorts them together, which is not a good thing. It means magnetic flux can flow through the screw to the next one, which, although it's only small, well, it's not a good thing if you can eliminate it. And they've eliminated it with these little plastic inserts, which the screw, very thin screw, goes through, so it doesn't short out against the case. And also, a double thing it does. Also, it's locates the ends nicely. There's no play when it's done up, so it's not offset one way or the other, though I don't think it would be. This one was a bit funny because it's right where the screw goes through, right where the solder tag is, so they've had to put this insulator pass through a hole, and then they've had to put another insulator on the other side to stop moving around really, but it's resulted. I've taken apart the Fantom icon, the SMC Low resistance. When high current flows through there, this tag has got a bit of a resistance. I've measured the coil resistance obviously with a low current, but when you pass a high current through, that part could heat up possibly. It's just the way that they've done it. The screw goes through there now. Besides that, you've still got the screw on this one. A lot of people think that this screw takes away from the performance of the motor. It's so small, and unless it shorts these out, like I just told you, I don't think it does anything that you can measure to the performance of the motor, unless it shorts it out. So they got them in plastic tubes. The front is hasn't got any holes in it for strength, I guess. They've got the offset mounting holes so the motor can be raised up or down, as whichever ones, and hope you don't strip them out. You've got to mount it low. You probably don't want the tags under the car. You might have to undo it and turn it round to make sure your connections are in the right place in your car when it's mounted on whatever sort of plate, whether you've got a side plate. Most plates are at the bottom of the chassis, but not all. So we come on to the icon. Now I couldn't understand why it spun. It appeared to have no magnetism at all, but when I took it apart and got the rotor out from the Fantom, it turned out to be a very strong rotor indeed, over 1500 Gauss. The reason, as I just explained earlier, was they've got such thin part of the stator around that wraps out the magnet, and probably a thin leg. It's just taken away all the magnetism. On about the patented penned in tuning pins. Well, I couldn't work out what they were going on about. I couldn't see any tuning pins. What is this tuning pin? When I took it apart, I discovered there are these pins which go through where you'd normally screw a normal motor together by passing the screw all the way through and screwing the back to the front. But now they have these pins go in the slots. But I thought the whole point of doing away with that is you don't have this pin which might short out the laminations, and also with some people think takes away from the performance of the motor. And I was surprised to find, I thought, yeah, this is going to be great. No front to back screw, just what people always wanted. Then we find that the screw is there, but it's a pin and without a screw head. Not only that, there's tiny little grub screws that screw into the original threaded parts, where if you pass a screw through, it'd screw up through these threaded parts here. Now you push this in, and it does go all the way down, and now you put a tiny grub screw and you screw it into that hole till it pushes on this, and I'm not quite sure what it's supposed to do, because this then will push, as far as I can see, it pushes on the end bell. Maybe it's to take up the slack. I'm still a bit mystified what the whole point. They call them tuning pins. I'm not quite sure. Anyway, I thought the whole point of this was it's got 3 screws hold it together. I didn't think you were going to have the original screw that went through still in the motor. I look at the rest of the motor. This has been forced in or glued in or something. It doesn't come out. There's a standard design that you see in a lot of motors, riveted connections. They've got an aluminium part collector at the front. You can't quite see it. It's not as thick as some others, but at least it's there. Standard bearing. Sensor board changed differently. A different make. Anyway, the effect is the same. It seems impossible to get them perfect, and you get good ones and you get bad ones. Insulator again, that goes on there. I did measure the Gauss. As I said, this one's the Icon. I was surprised to find it was such a strong magnet, because it's so the SMC one. The Gauss was only 1469, 1474, but it felt so strong, and that is because it's got such a nice thick web and leg. The rotors themselves have various things written on them from 19597. It's also got 19597 on there. SMC one says 712542, but on the shaft it's got 7.25 by 12.5, so you know it's a spec. Go quickly to the Revtech Xfactor. They seem to have done it what I would have thought would be correctly. Here's a side view. The little 3 screws on the back now. Let me show you the back. 1, 2, 3. That just holds it, screws into the case, holds it all together. I thought that's what the Fantom was going to do, but as you can see on the Revtech, it does actually do what I thought. 3 screws there. They don't go all the way through. It's hard to see, but if they went all the way through, they'd have to be screwed into the front somewhere, and they're not. This has just got 6 motor mounting screw holes. The screw doesn't come all the way through and screw into the front or do anything. It's a short screw. It doesn't have a pin or anything, which I thought was the whole idea. So the Revtech, in my opinion, got that idea right. I don't know, I don't understand this Fantom tuning pin thing they've got at all. To measure the stator winding resistances, first I zero the meter by connecting the silver plated connections on each together to get and adjust it inside as a pot to get the 0. Then we can measure, for instance, the SMC distance on the 13.5. 0.021. Oops, do all three poles. Do the center one to the other one. 0.021 and do the one on the other side. 0.021 all round. Let's just compare it to the other figures I've got for 13.5s. Yeah, pretty good. R1 0.021 and the surpass 0.021 there. So it's as good as any of the others. Fantom 17.5 icon stator resistance, 0 the probes. 0.038 to the middle one. 0.037. Third pole, between 0.037 and 0.038. How's that compared to the previous one? So according to this, it's a bit out. We had 0.036 for the surpass and 0.035 and possibly even an 0.034 on the R1. So it doesn't look like it's as quite a class leader, but it's not far off. And just quickly, there's a Turnigy 13.5 Outlaw motor, completely illegal, but you can see it's wound 0.035. It's a pretty low resistance. 0.034. That's one reason why it's an outlaw motor. It's got illegally wound. The SMC KB reading, when I've set to 6.0 amps, is a nice 4319. Timing was average of 41, a bit of a spread, 41, 38, 44. And that is nearly spot on what they say about the timing. Needs 8 degrees less. Normally other motors would be about 50 degrees, so this is 49. It is literally 8 degrees less than another typical motor. The timing of the SMC, it's a tiny mark between the 40 and the 50, which means it's indicating about 45, and we got 41 on the tester average. The Fantom icon 17.5 set to 6 amps to compare kV with other motors. Now they say in their blurb, the most insane RPM ever seen before. Well, it's 3378, and is that the most insane? Well, I'll show you the comparison with other motors later on. Let's just do the timing as well. Timing of the icon, average of 48, and the spread 49, 47, 49. So this one's actually got a nice sensor board. This one's got pretty clear graduations, and you can see, according to this, it's set between 40 and 50, about 44. So it's way off being accurate. On the tester it came out at 48. Weight of the motors, 13.5 version, 136.1. Quite impressive, because the R1 weighed 143, but surpass is still fairly heavy, 155, but with the hobby wing 132.4, so they haven't beaten that. That's a good effort. 136.1. I think the Reedy was fairly light as well. Yeah, Reedy, that was way back too when that came out. There's the S++, 146.3. So it's in second place. The Fantom 17.5 turn weighs 145.6 grams. How does that compare? R1 143.1 and the surpass is 152. So that is a good low weight now. Almost a second again to the R1. Reassembling the Fantom icon, you've got these tune-in pins which go in place of where the screws would normally go through on other motors. Then on the other side where they'd normally be screwed through, you've got these little grub screws. So 50 thou .005 hex driver, if you're trying to find one to fit, they have to be screwed in on this side. Back you've got this insulation plate. Check that you've got the shibs in the right place. When you put the rotor into the rear bearing, the face should not hit. There should be a gap between the face and the sensors. So the other shims will go on the front. Now it's quite difficult to put these into cans, but if you've got one of these little tools that lines it up for you, and assuming that you've got the correct shims and you haven't lost any, they go on the front, and that should go in like that, and you can take that out. Then I normally push it back through like that, put this on, work out where it goes. Normally has A, B and C, which helps. Keeping your finger on the shaft so it doesn't come flying through. Try and ease it down. Eventually it goes on like that, and it's quite a tight fit. It's like that tuning pin has to be pushed right in. It's quite tight. And once they're in, 3 of them, go in those, and they push the shaft along. I don't understand what the tuning factor is. Put the final one in. So you've got 3 of these things that screw in, and they push on the pin. I just don't know what the point is. You do it up until what? You don't want to do it up too tight, otherwise it's going to be pushing really hard against that end bell. Well, I've screwed them in, I haven't screwed them in tight. I don't know what the point of that is. Shim nicely back together. Whoops, a slight problem. I was going to test the motors. I've got the Icon, the SMC, and I was also going to do the Turnigy Outlaw on the dyno. We've got the clamp here which clamps the motor in, normally fits in and tighten it up, which holds the motor in tightly, but of course with the SMC, which is now small diameter, it just rounds about. I can't clamp it up. And the same with the case of the Turnigy, it's also the same size. Had to wrap some like battery strapping tape round. A rubber sleeve would be better if I had one, so that it now will fit tight enough in there so I can clamp it up. Got the Turnigy in there at the moment, just make sure it works. Got the battery is fully charged at all times by running a charger on it to keep it topped up, so all the results are exactly the same. Speedo's in Blinky mode, sensor lead connected. This motor has been tuned to 6 amps, same as all the others, so we can do a comparison. Just on the efficiency run on the Turnigy, so over here we've got a nice curve for the efficiency versus RPM. I'll show you that later when we compare them all. Quick look at some results from the MiniPro dyno, and they're recorded on the graphs. We'll just have a look at a couple of things. The Fantom 17.5 Icon and the Turnigy Outlaw 17.5 turn, and I've also got the results from an R1 V21 17.5 turn, all tuned to 6 amps off load and set to Blinky mode. The R21 was done with a slightly different program setting, it doesn't matter. We can see the RPM achieved. Brown one is the Outlaw, so it only achieved about 20,000 RPM. The Icon got to above 22,000 RPM and it's beginning to flatten off, but the R1 was still accelerating here, and it was nearly up to well, it's over 23,000 RPM. So I'm not sure about the Icon with its insane RPM, because the Icon, the R1, achieved a higher RPM. Another thing to look at is the efficiencies. The efficiency curves for the Fantom Icon 17.5 turn, the Turnigy Outlaw 17.5 turn, and the R1 V21 17.5 turn. The blue one is the Fantom, the brown one is the Turnigy, and the green one's the R1. The efficiency curves should be over 50%, and the higher the efficiency, less heat in the motor, and the generally better constructed it is. Now the Fantom, I only got it peaked just below 50%, whereas the Turnigy did well, about nearly 58%, and the R1 was about 56, 57. But the other interesting thing is you can see the efficiency curve here gives you where the RPM, where you can gear it. And the efficiency curve goes over the top, and then it starts losing power, and you normally gear hit the gearing about here. It goes over the top, and then you're just taking too long, becomes inefficient, and it won't be pulling. And on a long straight you gear over the top of the efficiency, you might hit about here. Now both of these, the Fantom and the R1, looks like they could be geared about the same. 20,000 RPM, if you keep going, 22,000, anywhere between around here, 19, 20,000 would suit that motor. Now the energy peaks out, comes down pretty fast here, and that's way down, maybe only 16,000 RPM. It's not a revvy motor, so you're going to gear it totally different. If you've got a long straight, it's not going to achieve the RPM, but it's very efficient if you can work it in this range. If it was running at a constant speed, it's an efficient motor. We know that though from when the resistance is the lowest out of all the motors. The Fantom resistance was higher than the R1, and it just shows up in the efficiency curves as well. Looking at the torque versus RPM, the green one is the R1, the blue is the Fantom, and the brown one is the Turnigy. Now the Turnigy you expect to be it's lower revving, you thought it would be higher torque, but it hits the maximum torque right down here, about 9,000 RPM. The Fantom hits maximum torque about 8,000 RPM, and the R1 torques out really early, right down here at 5,000. But when you go up here towards the, say, 18,000 RPM, you can see the torque has fallen right off on the Turnigy. The Fantom's about in the middle, and the R1 still got reasonable torque, so it's still got a bit of pulling power at the higher revs. So again, usual result, I thought the torque on the Turnigy Outlaw would be higher, but it's actually not. We've got the power output you can look at as well. The R1, it peaks here, and the Turnigy is, that one peaks there, and it looks like the graphs are slightly out, but the Fantom peaks there slightly lower as well. Quick look at efficiency curves for the SMC Low Rider, the blue one, which is a 13.5 turn, the R1 V21 13.5 turn, the green, and also the Fantom 17.5 turn, just showing the difference between 17.5 turn, 13.5 turn set up at 6 amp Blinky. We can see that the Fantom is only going to achieve about 20,000 RPM before it runs out of steam, whereas that's 17.5, whereas the 13.5 turn motors, they got a much stretched out efficiency curve, and they can go right up here 25,000, and you can see that the R1, the green one, is actually better than the SMC. It's slightly more efficient, and you can stretch it a little higher before it loses performance. Conclusions about the new Fantom Icon motor and the SMC Low Rider, new insane spec motors for 2019. And I've analysed them particularly for the spec racing, car competition racing, which would be 13.5 turn, 17.5 turn, Blinky 0 time speed controls. In 10th scale, 2S cars also can be used in 1S on road vehicles. And that's what I've analysed it for. There are lots of other motors around that can be used for other applications, but we're just looking at these for this application. Now these are two new ones for 2019, and I've also looked at the results from the Turnigy Outlaw motor just out of interest, and I've been over what's going on with the insides of these motors. Also, this Revtech Xfactor, haven't got one yet, but we looked at the design and spec and it looks interesting. So just briefly before I look at the results, the motors, the SMC actually looks like it's a shrunken version of the other motor. It physically looks smaller when you look at it because it hadn't got an outside case like the red one. The case is missing. Good idea. I did show that it's been done before, could have been done before by Turnigy, which has been around for ages, and possibly others as well. And I looked at the inside here about all this construction of the stator, the size of the legs and everything, and how the wires are grouped in wound round in little bundles, and if you've got a bigger gap you can wind a bigger bundle, and if you run 17.5 use different gauge wires. Well, let's look at the results. Previously the 17.5 and the 13.5 turns, the best results I've seen are the R1. Some of the other motors like Surpass come very close indeed. Fantom 17.5 turn. Fantom themselves, as earlier on I said, patented tuning pins, and they spoke of most insane RPM ever seen. And you can turn the timing up on the M bell to get insane RPM with any motor, or have a very, very weak rotor. I always test them at 6 amps off load, which gives you a comparison between the motors. It tells you the revs per volt, which is best as a kV figure. Got the results previously here to compare. So one thing is the weight. 145.6 grams is quite light. The R1 weighs 143.1, so it didn't beat that. And the hobby wing was the lightest. I don't know if I've got that result. But anyway, it is a lightweight motor. Even though it's still got the full case on it, it's still pretty light. It's lighter than the Surpass, for instance, 152. One of the things that will determine how good a motor is the stator resistance. It just about reached how far you can go with stator resistance, winding the coils as tight as they can within the rules, using the correct gauge of wire. We've got down to, I measured 0.035 and 0.036 with the Surpass and the R1. And that, I don't think you can get any lower. If any motor goes below that, it's got an illegal winding in my opinion. It's got turns missing, or it's got extra multiple winds. Now the Turnigy's got additional parallel winds. It's got the room to do it, and they got it down to 0.034. Now if you ever measure the resistance of a motor, one of these, and you get 0.034, that's just about limit. I've never seen a motor that has not been wound correctly ever, and all the poles have always been the same. So if anything is way below that figure, it's not right. It's something wrong with it, and it can't possibly be legal in my opinion. What did we get with the Fantom? Well, I only managed to get 0.037. I use a pretty accurate resistance meter. I make sure it's calibrated to 0 and I check it. So their winding is slightly higher. So that means the efficiency, it will a little more heat. Carrying on. KV. Alright, we might as well say that they say it's insane KV. Well, KV per volt, I got 26,000, but the KV is per volt, so make sure you got the right voltage going in. Anyway, I've got a 3378 kV. If you look at the R1, I've got a 3403, almost the same. And the surpass varied, and I actually had a 3688 I've measured on the surpass, so if you're talking about insane, that one was. I can't actually say it's insane, it's good. And that was achieved, the timing board's not bad. It's 49, 47, 49, which is nice. I've had other ones just as close, 51, 51, 50, 52 I mean. And the surpass, I've had them pretty close, 52, 51, 51. Check the rotor strength. It was strange about the rotor strength because it appeared to be weak, but as I explained, by using rather a thin stator design, it lost some of that torque effect. Probably make quite a smooth motor, but the rotor strength was high. 1537 minus 1548, and that's around about. The surpass was only 1505, 1537 on one. Another is lower. And the R1 was only 1462, 1470. Though they do vary. The ones I've measured lately have been more like 1500. The Turnigy was a very strong rotor, 1536, 1564, just like this one. But completely different feel. The Turnigy was very clunky because of the extra thick stator. The Fantom, it's got tuning pins which I don't understand, which run in there, held in by grub screws. The rest of the design is nice with these 3 screws on the back to hold it together. I think you could probably leave those pins out or take it apart and discard them. I don't know what they do. The rest of the motors are nicely made. It's quite a nice red colour. Timing, bearings. Shaft protrusion is short with a nice flat part for your pinion all the way up to the face. And the holes are equally spread around the front. Move on to the SMC 13.5 turn. They talk about the motor has a lot of kV, but they don't say insane, they just say a lot. And it requires less timing because rather than conventional thin leg, it's got less, well, more accurate resistance. All the ones I've tested, pole to ABC on every motor is pretty much tight. They don't vary. Nominal power. Let's have a look at it. Well, I do like the fact that it's this small diameter, offset holes, so you can mount it in your car correctly. And the weight, 136.1 grams, which is impressively lightweight compared to, say, V21 143. So it beats that one easily, and the only ones it doesn't beat, going back to the Hobby Wing, 132.4. Really 146.3, but it did beat it. So a really nice lightweight motor. What about the performance? Again, they're saying it's got high kV. R1's a kind of class leader at the moment, so let's just look at the R1. MC at 6 amps, got a kV of 4319. This is a 13.5 turn, remember? And that is pretty impressive. The SMC compare, the class leading R1 V21 13.5 turn. Well, this is the standard one. It did 4172 kV, and the SMD's done 4319. That is higher. The surpass, they varied. I did a couple, 4175, 4310. So that is close to a good surpass one, and it beats all the other previous ones. Nothing has gone into the 4000s for some time. And the Orca Blitroom is a good motor. So it looks like the SMC has achieved a very good kV. And the timing, they say it's 8 degrees less, and they're spot on. A normal motor draws about 49, 50 degrees, 48. There's only 41 degrees to achieve that. So far everything they've said about their motor has been correct. What about the all-important stator winding resistance, 0.021? Right down with the best. The R1, the surpass, 0.021. Now that is about as low I reckon you're going to get with it again with these windings. If you see a motor that's 0.020, perhaps on one pole, all three poles, I would say, if it was done on a calibrated meter the same as mine already, that is a motor, unless it's a new one we haven't seen, that is in the envelope. And anything past the 0.020 lower, I would say, was definitely suspicious and should be investigated on its construction or number of turns. Strengths. SMC has a 1474 minus 1469, a pretty nicely matched north-south Gauss, compared to 1461 on, so very close to the R1. And on the surpass, they tend to be around the 1500 mark now, the surpass ones, all the ones I've tested quite a few. This was a 1520 minus 1544. Things to note: shaft protrusion, 1431 surpass is only, well, it's 13.8, so bad. I've seen longer. Size is nice and small. The offset holes, so you can mount it low in the car. Low Rider, good name. It is a Low Rider. I'm very impressed. I'd like to test the 17.5, which I haven't been able to get. And if it performs as well as this one, it's going to be one of the class leading ones, up with the R1 surpass, maybe even beating them, because it's lighter. It's got the low riding mounting, small diameter. Cooling, well, there's nothing to keep. It's got holes. They've achieved a very good motor. There's a massive gap in the front. They could have made it even shorter. And if they'd put like a silver-plated aluminium big collector on the front, I think they'd improve that motor even more. I think there's more to come from that. So that is those. The Xfactor, I would like to test that, see how good it is. Looks good. Looks very good. That'll be later. So in conclusion, the SMC lived up to its the blurb that they put out about it. The Fantom, maybe I'm missing something about the tuning pins. Maybe it's possible to adjust the tuning pin to get insane RPM. I didn't manage it. And I hope I've explained about why you can't get any more performance out of these motors without somehow bending the rules. There's people who say the tests on KBE aren't good enough and you need torque readings. I did do tests on the MiniPro Dyno and showed you some of the curves. It's very difficult to show up the differences. I think the efficiency and the RPM, which equates to the kV on a normal off-load test, and the resistance test of the winding gives you a very good indication of how a motor is going to work. There you go. I hope that was of some use. On the next innovation, if what someone else can think up.